Hello student, welcome to all of you in the next physics lecture. In this lecture, we have to see the different laws of vector. There are the different types of the laws of vector: triangle law of vector, law of parallelogram, law of polygon. Just we have to see here the triangle law of vector. You have to ask the question like this: state the triangle law of vector. State and explain the triangle law of vector. The statement is that from this diagram, this is the triangle having the three sides. Then we can state this triangle law of vector in such a way that if the two vectors are represented in magnitude as well as direction, if the two vectors are represented magnitude as well as direction are the two sides of triangle taken in order, and these two sides are which are the sides of the triangle and which are taken in a order, then their resultant as shown in figure, this is the resultant. This resultant is also represented the magnitude as well as direction. This resultant is also represented magnitude as well as direction, but which is the remaining sides of the triangle, that is the third sides of the triangle, and which is drawn from starting point of the first vector and end point of the second vector. And the condition for these third sides of the triangle, which is drawn in such a way that which is drawn from the starting point of the first vector and end point of the second vector. This is nothing but the statement of the triangle law vector. Again, you have to see here the statement of this triangle law of vector from this diagram. We have to consider here the triangle, because this is the triangle law of vector. Triangle has the three sides, and so that we have to start here in statement, that is, if the two vectors are represented in magnitude as well as direction. This is the first sides A bar and second is the B bar, and resultant is here C bar. That means if these two vectors which are represented, because they are the vectors, so that they can be represented magnitude as well as direction, and which are nothing but what? The two sides of the triangles which are taken in order, then their third sides, that means their third sides of this triangle, which is also represented the magnitude as well as direction, that is the resultant of this triangle, which is nothing but also represented the magnitude as well as direction, and which is the remaining sides of the triangle, and which is drawn from starting point of the first vector and end point of the second vector. Starting point of the first vector and end point of the second vector. This is nothing but the triangle law of vector. Now we have to also solve this some example from this triangle of vector. See here in your book. Suppose from this following figure we can determine the resultant of these four vectors a1, a2, a3, a4. In diagram you have to given here the four vectors a1, a2, a3, a4, a5. Then you can draw these resultant vectors of these four vectors. How you can be the determined? Then you can join the OB. Then the resultant, this vector OB, is nothing but a1 bar plus a2 bar. This is equal to OB bar. If you have to draw this OC bar, this is the resultant OC bar. Okay. Then this resultant is nothing but the vector a1 bar plus vector a2 bar plus vector a3 bar. This is nothing but that is equal to the resultant vector OC bar. Also you have to draw here this resultant vector OD, this OD, which is equivalent to, how it can be written this OD, that is this vector a1 bar plus a2 bar plus a3 bar plus a4 bar, and this is nothing but the OD. In such a way that you can determine the resultant of these four vectors. Show this figure. First we have to draw here the first resultant, and this is nothing but the addition of these two vectors. Therefore, this is the resultant OB bar, and which is equivalent to vector A1 bar plus A2 bar. Right here we have to see here OB bar, this is nothing but the OB bar, is equal to OA plus AB. That means A1 bar plus A2 bar. Right, this is the resultant. This is the first type. You can draw this first resultant vector. Second way, we can also find out this resultant vector in such way that OC bar. This OC bar is nothing but what? OA bar plus AB bar plus BC bar. That means A1 bar plus A2 bar plus A3 bar, like this. This is OC is nothing but the resultant vector. Thus, this OD bar is the resultant of these four vectors. This OD is nothing but the resultant of these four vectors, and therefore this A1 bar, A2 bar plus A3 bar plus A4 bar is equal to this resultant OD bar. Okay, you have to understand this example. Then we have to see here the next law, that is the law of parallelogram of vector. For that purpose, we have to also draw the diagram, the law of parallelogram of these two vectors. And this is the parallelogram. You know this well. This is the parallelogram. Then you have to ask this, state and explain the law of parallelogram of vectors. First, you have to draw the diagram. This is the parallelogram, two parallel sides, OA and BC, and here OB and AC. And this is the diagonal, that is the OC. This is the resultant. Then how it can be state this law of parallelogram? If again we have to start here, if the two vectors P bar and Q bar are represented in magnitude as well as direction, because they are the vectors, so that these two vectors are represented in magnitude as well as direction, but these are the adjacent sides of the parallelogram. These two sides are the adjacent sides of the parallelogram. Then their resultant is also represented magnitude as well as direction. This OC bar, that is the R bar, is equal to P bar plus Q bar. This is nothing but the resultant. And this resultant, which is also represented magnitude as well as direction, but which is the diagonal of the parallelogram, which is nothing but what? Diagonal of the parallelogram, and which is drawn from the common point of these two vectors. This is the condition. This diagonal we can draw. How it can be drawn? The common point of these two vectors. The starting point of this diagonal is nothing but the common point of these two vectors. And this is nothing but the statement of the law of parallelogram of these two vectors. See again the statement for this law of parallelogram. If the two vectors are represented, the magnitude as well as direction are the adjacent sides of the parallelogram. These two sides are the represented magnitude as well as direction, and which are the adjacent sides of the parallelogram. You know that well this. Then the resultant is also this OC, that is the R bar. This is nothing but the resultant, which is also represented magnitude as well as direction, but which is the diagonal of the parallelogram, and which is drawn from the common point of the two vectors, which is starts from the common point of the two vectors. And this is nothing but the a statement of the law of parallelogram. Okay, if you have to understand, then we have to also solve this parallelogram of law of vector with addition. How it can be resolved? From this diagram we can resolve by using the Pythagoras theorem and this law of parallelogram of vector addition. We can find out the magnitude of this parallelogram. To find out the magnitude, we have to consider here this OA. This is the P bar. This is the parallelogram, this P bar, then this is also P bar. Okay, because this is the parallelogram. Then this OB is equal to Q bar, then this side is also Q bar. Okay, this is the resultant R bar. R bar is equal to P bar plus Q bar. Then this angle of inclination of these two vectors, this is nothing but equal to theta, and this one is the beta and this one is the gamma. Then again we have to construct here this OA, which can be the produce, and draw the perpendicular CD to the OA produce. We can draw the perpendicular dotted line. This is the construction. the CD perpendicular to the OA produced, and so that this is also a right angle triangle. Then we have to use here the Pythagoras. They are the right angle triangle. Okay. Then this, if you have to make this raw material to resolution of these two vectors by using the law of parallelogram of vectors, then by using the mathematical this we can solve this magnitude of this vector r bar. Suppose we have to consider here these two vectors p bar and q bar, and OC is the resultant, that is the diagonal, that is the resultant vector, and this this triangle COA, this is nothing but the we have to consider here one triangle. Then CBO, this is also one triangle, and by using this Pythagoras we can find out this magnitude in such a way that we have to consider here in this right angle triangle ODC. We have to consider here right angle triangle. Okay, you have to see here. Okay, this is the diagram for this parallelogram law of vector addition, and to find out the magnitude we can draw the perpendicular CD to the OA produced. Then this angle is the theta, angle of inclination. Then in right angle triangle ODC, this is the O, this is the D, and this is the C. ODC, this is the right angle triangle, and by using the application of Pythagoras theorem we can write here. We know that the Pythagoras theorem, how it can be write, this hypo OC square is equal to OD square and plus CD square, like this. OC square is equal to OD square plus DC square or CD square. Okay, then instead of OD we can write here OA plus AD. We can split this OD in such a way that OA plus AD we can write here. OC square is equal to OA plus AD bracket square and plus DC square. Okay, then expand this OA plus AD. How it can be expand? OA plus AD, first terms square plus second squares, and then first into second and twice. Then see here, OC square is equal to OA square plus twice OA into AD. Okay, then plus AD square, and last one is the DC square. But if you have to see here, AD square plus DC square in this triangle ADC, ADC in this triangle, this is the hypo, only this triangle ADC. This AC square is equal to what? AD square plus CD square. But instead of AD square plus CD square we can write only AC square. That means this AD square plus CD square we can write only AC square. Okay, by using this also the application of Pythagoras theorem, instead of AD square plus CD square we can write simply AC square, and so that OC square is equal to OA square plus twice OA into AD, and instead of AD square plus CD square we can write by using the Pythagoras theorem AC square. Now substituting the values, we know that OA is also P bar, then AC we can write this is Q bar parallelogram, this is also Q bar, and then again OA, this is P bar. But we can find out the AD by using the trigonometric relation cos theta. We know that the cos theta is nothing but what? The adjacent upon hypo. Therefore we can write cos theta is equal to AD upon hypo AC. See here, cos theta is equal to AD upon AC. Therefore AD is equal to AC cos of theta. AD is equal to AC cos of theta, and AC we know that this is Q bar, this is AC also Q bar parallelogram. Therefore Q cos of theta, value of this AD is nothing but Q cos of theta. Therefore AD is equal to AC cos theta, and instead of AC we can write Q cos theta. Then substituting all these values in this above equation, this OC is nothing but what? This is the resultant R square. Therefore we can write here R square. Okay, R square. Then this OA square, P square, AC square, Q square, Then this twice OA into AD, we can write twice P, and instead of AD, we can write here Q cos of theta. Therefore, R square is equal to P square plus Q square plus twice PQ of cos of theta, or taking the square root, R is equal to square root of P square plus Q square plus twice PQ of cos of theta. This is nothing but this equation is the magnitude of the resultant vector R bar. This equation is nothing but what? Resultant vector of this R bar. You have to ask the numerical by using this formula, small r is equal to, or r square is equal to p square plus q square plus twice pq of cos of theta. Then also we can find out the direction of the resultant vectors of this R bar by using this triangle D ODC. We have to consider the ODC. Then we have to find out the tan alpha. Tan alpha is nothing but what? This is a trigonometric relation, opposite upon adjacent. That means CD upon AD. This CD upon this OD, all over this OD. Again, this OD we can write OA plus AD. And from this we can find out the value of DC in such a way that by using the trigonometric relation, sin theta is equal to DC upon AC. Again, as same above, DC is equal to AC sin theta. AC is nothing but what? Q sin theta. Also, we have to find out the cos theta. AD is equal to AC cos theta, or AC is nothing but the Q cos theta. Then substituting this value, we can write here tan alpha in this triangle COD. This tan alpha is equal to CD upon OD, but instead of OD we can write OA plus AD, and substituting all this value, tan alpha is equal to Q sin theta upon P plus Q cos theta. And we have to find out the only this angle alpha, then take this side, then alpha is equal to tan inverse of Q sin theta upon P plus Q cos theta. This is nothing but the direction of the resultant vector R bar. By using these two formulae we can find out here. One is the resultant vector R bar, and second one is the this tan alpha Q sin theta upon P plus Q cos theta. These two formulas are the very important. By using this formula we can solve these numericals, and which is very important. Okay, you have understand well. Let's stop here. Thank you.